Hi, we're going to look at arithmetic sequences right now. So in an arithmetic sequence, each of the terms is going to have a constant difference. And the way you're going to find that is you take two adjacent terms, so any two terms next to each other, and subtract them, and that'll be the difference. And you're going to want to use the one to the right minus the one to the left. So the one that occurs later in the sequence minus the one that comes before it. So if you were going to find the difference for the odd numbers, you would take 3 minus 1 equals 2. And so 2 would be your D, your distance or difference. And that's what you would put in here, which I did right here. So they're two away from each other. We can also do that with multiples. If we look at 3, 6, 9, 12, we see that we just added 3 to each of the preceding ones. So an arithmetic sequence is often defined recursively because we're adding to the previous term. Other times we don't have to have whole numbers in this case, and they don't have to be positive. So we don't always have to increase, we can also decrease. So for this one, we start at 12 1/4, we go down to 11, then down to 9.75. So we just subtracted two adjacent terms, so 9.75 minus 11 will give us negative 125. So our difference between them is negative 125 because we're going down. If we were going up, it would be positive. Going down is negative. So our difference can be either one. It doesn't matter. Now, if you want to find the 15th term of your sequence, you don't want to just keep adding that difference each time. So we have a formula. We have our initial and which one we're looking for and our difference. So we're looking for the n. So whatever our n is, it would be n minus 1 times our difference. And we add that to our starting term, and that'll find it for us. Let's take a couple of examples of these. So here we have this sequence, A1 equals 3, our distance is 4. We want to find n equals 8. So we have n equals 8, so we want A8 equals 3 plus 8 minus 1 times 4. So it's 7 times 4 plus 3 is A8. So that's 28 plus 3, and that is 31. So our 8th term in that sequence is 31. We can also find the 15th term or the 99th term. I'm going to skip ahead and just do the 99th term. Instead of plugging in each one like we did for the first few, if we want to go up to 99, we say, okay, the first term is 3 plus 99 minus 1 times 4. So it's 98 times 4 plus 3 is our A99. So A99 equals 3 plus 392. So A99 is 395. Now let's take a look at the next one. So A67, we have a distance or difference of negative 3. So if we have n equals 8, so A8 will equal 67 plus 8 minus 1 times negative 3. So it's 7 times negative 3, so negative 21 plus 67. Let's finish filling all this in. And so this gives us 646, if my calculations are correct. Okay, so A15, let's change that color here real quick. Oh, A15 is going to be 67 plus 15 minus 1 times negative 3. So we have this equals 67 plus 14 times negative 3. So 67 plus negative 42. And that's going to equal a positive 25. So A15 equals 25. Let's take a look at A99. What happens here? So if we have agent 99, that equals 67 plus 99 minus 1 times negative 3. I'm really glad I don't have to plug in all 99 terms and calculate each one individually. So this is 98 times negative 3. And actually there are ways to show that this is true without doing all of those calculations. That's how they figured out the formula. In fact, it's a little bit of the distributive property. So negative 3 times 98 is negative 294. And we add 67 to that and we get negative 227. So we can see we can get larger, we can get smaller. It all depends on what we're working with. Let's do this one last example, and in the meantime I'm going to erase the screen so that we have a little bit more room to work and just look at this last situation. Okay, so here we have A1 is 4 and D is negative 2. So A8 is going to be 4 plus 8 minus 1 times negative 2. So we have 7 times negative 2, which is negative 14. And again, we fill in all the rest. Just bring it along. Don't forget about it. So A8 equals negative 10. So I think you might be seeing what's going on. Let's do one more on this problem. So A15 is going to be 4 plus 15 minus 1 times negative 2. So A15 is 4 plus 14 times negative 2, but that's just negative 28 plus 4. So A15 in this sequence is negative 24. So I hope this helps you finding your arithmetic sequence values. So you might be given a sequence, figure out a way to write it in general, and to do that you just find the difference, and if you want to find some arbitrary term you just use this formula. AN equals the first term plus n minus 1 times our distance.